Welcome back to our topic on properties of the periodic table. We've looked at the alkali metals and we've looked at noble gases. Today's lesson, lesson 3, is on the halogens, group 7. If we look at our periodic table, we can see group 7 is here, this column here, this long column with a 7 at the top. And hopefully you can see here I've used the L of halogens. I've made it a 7 to help you remember group 7 is called the halogens. You do need to know that name and that number. Hopefully you also recognise that that group is beyond the zigzag line and it most definitely falls into the non-metal category. So halogens are non-metals. Now, sometimes we use the word halides. You'll hear the word halides when talking about the halogens. We'll look at that in more detail next lesson, but it simply means when they've reacted with an acid and they're making salts, we talk about the halide salts, so salts made with the halogens. So that's just that connection there. So I just want to look at more detail at this periodic table. You should recognise this periodic table. It's the one you get in school and it's the one that you get in the exam hall as well. So here we are, we're looking at group 7 and you'll notice it's a 7 in brackets, not the 17 just underneath. So make sure you're looking at the group number in the brackets. But what does that number actually tell us? Well, it tells us they are group 7. So we've got fluorine, chlorine, bromine, iodine and acetylene. But what does that number 7 actually tell us? Well, you should know that number 7 is called group 7 because there are 7 electrons in its outer shell or outer energy level. So it doesn't matter which of them, which elements it is, whether it's fluorine, chlorine, bromine, iodine or acetylene, they all have 7 electrons in the outer shell. So some of them only have 2 shells, some of them have 4 shells, but the outer shell always has 7 electrons. Now that means it's unstable. It needs more electrons to become stable. So halogens are reactive because they want to fill that outer energy level. It only needs one more to make our number 8. So 8 is a full shell. It only needs one more. And so every single time a halogen reacts, it's going to gain one negative electron. And that means every halogen will always have a -1 charge. So when it's an ion, that means it's gained or lost electrons. So when it's gained this electron, it only ever gains 1 electron, and so it always has a -1 charge. Well, why is that relevant? Well, if I asked you what ion will fluorine make, then were you thinking, well, is it group 7? Yes, it is. Well, then it will form a -1 ion. F -1. What about chlorine? Well, chlorine's also in group 7. So guess what? Cl -1. What about these 3 here? -1, -1, -1. They're all group 7. They all have 7 electrons in the outer shell, and therefore they all gain 1 electron to have a -1 ionic charge. If it's group 7, then it forms a -1 ion. I've used this little symbol here that we'll look at again when we look at our flashcard. Ion is always going to be a -1 for group 7. Okay, so today I want to look more in detail about trends. Now, some of these trends you need to know by heart. You need to learn them, you need to remember them. Others of them you'll simply be asked about them. So today, or first of all, I'm going to look at the atomic number. Okay, what is the trend of the atomic number in this column, in this group, group 7? Well, I'm going to need to look at my periodic table and I need to look and think, okay, well, which 2 of those numbers? I've got 2 numbers in each box there. Which one's my atomic number? Well, this is basic stuff, guys. You should know the atomic number is the smaller number. So if I look at number 9, then 17, 35, 53, and 85, those are my atomic numbers. And hopefully you will agree with me, as I go down the group, these numbers are getting bigger. So the atomic number is getting bigger as I go down the group. Now, how would I write that in class or an exam situation? Well, I could say, as we go down the group, the atomic number gets bigger. I don't like that phrase, gets bigger. It's not very eloquent. It's not very scientifically correct, is it? I could say instead, it increases. As we go down, the atomic number increases. So the question also asks about atomic mass. Now you need to know your atomic mass is your larger number. So again, we're going to whip through this. We're going to look at these masses here, these bottom numbers. You'll notice astatine doesn't have a mass. I wonder what possible question they could be wanting to ask us next. Okay, well, hopefully you recognise those numbers going down and getting bigger. So we might say simply, as we go down the group, the atomic mass increases. But what about astatine? Well, in reality, we don't actually have a mass for astatine because it's very reactive. It breaks down very quickly. It's very rare, and so we haven't been able to measure the mass. But we could make a prediction. So what do you predict about astatine? Well, I'm not going to have an exact number, am I? But I could predict that the mass of astatine would be bigger or greater than iodine. We know it's going to be a larger mass. Now, if I was being really on the ball, I might look at these numbers here and say, well, okay, how much are they increasing by each time? There doesn't seem to be a massively clear pattern, but if I say, well, okay, I'm going to add at least 47, my mass for astatine is at least 173.9. So that's adding the 47 again. Now, it's not going to be 173.9, is it? But nor is it going to be 3,000. This is about a logical guess. So don't ever be put off by putting a logical guess. There will always be a range of answers that an examiner would allow. Okay, they're looking for, do you understand it's getting bigger? And do you understand that there is a logical progression there? I'm not going to add 1,000 to iodine. So I just want to stop a second and just look at the logic of this increase in atomic number and atomic mass. It physically means if you were to be able to hold an atom in your hand, these atoms are physically getting bigger as you go down the group. Now it's going to be essential next lesson when we talk about reactivity. Okay, so here's the next trend. You do need to know this by heart for an exam situation, but we're not in an exam today, so don't panic. Let's have a look at the colour trend. So normally in class I'll be showing you some pictures, I've been showing some videos, but we're going to have to deal with just pictures today. So let's have a look. So first of all, the top of our column we've got fluorine. Now fluorine is a poisonous gas and it's this lovely yellowy colour. And I'm saying yellow, you'll understand in a second. So here's fluorine, it's a pale yellow colour. Here's chlorine. Now you can see why I've gone for fluorine being yellow, because it's more yellow than the chlorine. Chlorine is a definite green gas. It's a poisonous gas. Chlorine is one of the gases they use in chemical warfare. It is extremely poisonous. You get a lungful of that and you're a goner. Okay, next let's look at bromine. So bromine is this lovely reddy orange colour. And then iodine. Now iodine is a funny one. As a solid, iodine is grey, but very quickly it gives off this purple vapour. So you can see my colour there for iodine. I've kind of got this grey purple. The exam board want you to say grey. Okay, so iodine is grey, but just be aware it gives off this purple vapour. And then finally astatine. Well, astatine, again, still poisonous. All of the halogens are poisonous. Astatine is this poisonous black substance here. So what's the trend? What's the pattern in our halogens? Well, as we go down the group, well, we can't say it increases, can we? Because what's increasing? And we can't say it decreases. That doesn't make any sense. So we're going to have to be a little bit careful here. We could just say, as we go down the group, the colours get darker. And you're correct. However, more and more we're finding that we need to be a bit more specific. And so you would probably be a little bit clearer on this. You might just add a bit more detail and say, as we go down the group, the colours get darker from yellow to green to orange, red, grey and black. And you do need to know that trend. You would need to be able to label and name those colours. Please go on and watch part 2 of this lesson on the halogens.